Hey everyone, homework practice problems for Thursday, April 24th. So number one, it says to draw and label a net to represent the rectangular prism. Let each grid unit represent 1 inch. So you know you have the rectangular prism here. I, again, still like to do top, bottom, front and back, left and right. And if we take a look at our bottom, the bottom is going to be 3 by 5, which is 15 inches squared. So you know the area of the bottom is 15. That means the top also has to be 15. Okay. So what I would like to do here is I'm going to make my top and bottom. I'm going to base my entire drawing on that. So my bottom, if I know that's 3 by 5, all right, so the 5 is going to be this, and the 3 is going to be this. Okay. I'm going to use that. This is going to be my bottom. And then what I will do from there, I'll have the front be here, and I'm going to have the back be here. My left will be here, my right will be here. And then I can attach the top to this. I can attach the top to wherever I want it to be. That's up to you. I might attach the top to the right side just because I have more room to work with. Okay, so basically kind of set that up for you. Come up with your dimensions for your front and your back, your left and your right, and then add those accordingly, okay? All right, number 2, Trey is using cardboard to construct building blocks that are shaped like rectangular prisms. Use the net to determine the minimum amount of cardboard he will need. So if you are using a net, that's telling you this is going to be a surface area problem. So find the surface area, and again, we're gonna label top, bottom, front, back, left, right. And you can either use the net that they give you, or you can use this rectangular prism. They do show you, they give you a sneak peek into the back, into the left, and to the right. So again, you're just finding the dimensions of the top, the bottom, the front, the back, the left, and the right, all of those rectangles. And then you are, and actually, this is not a cube, although it looks like it could be a cube, but the dimensions have to all be the same. So you have 6 faces. You've got to find the area of all those 6 faces, each of the 6 faces, and add them together. Now you know the top and the bottom are congruent, left and the right are the same, and front and back, all right? Just like we did in class today. Number 3, again, this is going to be surface area. So it's up to you. Again, top, bottom, front and back, left and right. And I'm going to use, if I were to do this, I would use my 20 by 10 as my bottom, and I know my 20 by 10 will also be the top. All right, this is going to be the right. Okay, so the front is going to be this front right here, all right? Okay, moving on. Difficult question, man. Number 1, 2, 3, 4, and 7. So number 4, a little bit of a difficult question here. It says Jing is putting a special restorative stain on the entire surface of her rectangular prism shaped hope chest, except for her nameplate that measures 1/2 foot by 3/4 foot. If 1 can of stain covers about 35 square feet, how many cans of stain will she need to buy? All right, so listen, you're gonna need to figure out the surface area. Obviously the surface area of this rectangular chest here. So you're gonna have top, bottom, front, back, left, and right. And again, this is your front, 2 1/4 by 3 1/2. This is going to be up to you. My suggestion, I would change these to fractions. You could do decimals, but that's going to be a lot of numbers, a lot of decimal points. So, you know, 2 1/4 is going to be 9/4. 3 1/2 will be 7/2. 5 1/2 will be 11/2. I would use those numbers to help you, okay? And then when you get, after you're done multiplying, you're going to have to add, so don't forget you need some common denominators. So I'll help you out a little bit on this one. If we're doing the top and the bottom, we've got the top is going to be this, all right? And we know that it's going to be, let's see, 2 1/4 by 5 1/2. So that will be 11/2 times 9/4. When you multiply those together, you get 99/8. Okay, so 11/2 times 9/4 would be 99/8. So then 99/8, you're gonna have 2 of those dimensions, 99/8. So it's going to be 198 eighths, or combined for the top and the bottom. Okay? When you do the front and the back, the front is 2 1/4 by 3 1/2, so it's 7 halves times 9/4. But you're going to have two of them, so it'll be 63 eighths, but then you'll have to double that, so it's going to be 126 eighths. And then the left and the right, 5 1/2 by 3 1/2, so 11 halves times 7 halves, which will be 77 fourths, which would be, oh boy, 154 fourths. So the only problem that you're going to have here, you're going to have to convert this to eighths. This is a tough problem, all right? So change 154 to eighths, 154 fourths to eighths, and then you could add them all together. Now, once you add them all together, you have to subtract the nameplate, which is a 1/2 by 3/4. So you have to find the area of this nameplate. Luckily for us, it ends up being a fraction with a denominator of 8. And then you're going to subtract it from whatever you get from adding these. Okay? Yes, it's a difficult problem. You can do it. All right, and then the last one on this one, number 7. Find the surface area and volume of each rectangular prism-shaped block. Which block has the greater surface area? Does the same block have a greater volume? Right, you know, so again, you find the volume and the surface area of each one. Does the same, like you're comparing the surface areas and the volumes of both blocks, okay? So that's all you're doing. And these are all whole numbers, so we should be able to figure that out fairly easily, okay? So find the surface area and volume of each one and which block has the greater surface area. Does the same block also have a greater volume? So they're really asking you, if it has a bigger surface area, does it also have a bigger volume? Remember, don't always take that for granted. That's not always the case. All right, I will see you tomorrow.